Hello, dear students, online and offline. And there are technical problems with our transmission. I hope everything is solved. And there was a question about solutions of written exam. I hope your examinators will find out if there is a mistake in solutions and everything will be okay with it. But so in any case, during your oral examination, you will get a possibility to appeal about solutions, about grading for your final exam questions, it's for sure. And now let's start to discuss topics for our oral exam. So as I did before our first exam, I'll discuss every question step by step and with related places from either your lecture notes, which you can find on the site, or with reference to video lectures. First question, Taylor's theorem with Lagrange form of remainder. That is theorem 5.5.1. Let me write it down. So first question, theorem 5.5.1 from part 1. That is from the material of the first semester, right? So both formulation and proof practically coincide with what I gave during lectures. So of course you may also use my lectures from first semester if you want. Second question, that is theorem 5.5.7 plus lemma 5.5.1 from part 1 of lecture notes, or related part of video lectures from the first semester if you want. So first two questions are about Taylor's formula with different forms of remainder. Third question, of course, is a part of, I would say, necessary minimum for a sufficient grade, necessary and sufficient conditions for an extremum in terms of the first derivative. These are two propositions. Propositions 6.2.1 and 6.2.2, again from the first part of lecture notes. Fourth question is about sufficient conditions in terms of higher derivatives. That is proposition 6.2.3 from lecture notes, but it was given without proof. So proof, you should refer to lecture 28 of 12th January. It was during the first semester. Okay, so these were questions from introduction from calculus. Sorry, to calculus, right? So they are taken from the material of the first semester, right? Yeah. So now we start, from now on, I'll refer only to the second part of lecture notes, right? There is, I think it is labeled as second year in lecture notes, right? So Pankratov gave the material of the first semester during the whole year, maybe because of very bad level of his students 3 years ago. So you are better, I hope. Okay. Fifth question, basic general methods of finding a primitive. So that is section 1.3, ABC. What they are: linearity, the integral, integration by parts, and substitution. But also, what is important is to know basic table of basic integrals. So I understand that there are many integrals, but as you know, you were not asked about anything from integration. I didn't ask you any integral except for rational function, right? So only rational functions were necessary to success for a written exam. That is why I would like to ask at least best students to find an integral of a little bit more general form. That is why please try to remember table of basic integrals as well. Okay, sixth question. A Riemann integral. That is special question. Why I want to say special? Because, okay, definition with the help of integral sums. So please don't try to to find, to remember limit on base, don't touch it. So definition should be as follows. What is integral? Limit as diameter of mesh tends to 0 of integral sums tag it integral sums. So okay, so what it means for arbitrary epsilon greater than 0, there exists delta greater than 0 such that for all partitions with diameter less than delta, and for all xi I such that xi minus 1 less or equal xi I less or equal xi, we have an equality between I and the integral sum less than epsilon. That is the definition of the limit of integral sums, right? Please don't try to remember this definition in terms of limit on base. That is not necessary, because limit with the help of a base, that is another story, rather complicated, and we didn't touch it with sufficiently many details. That is why I don't want to touch it. So definition of limit of integral sums is given here, right? And don't try to use base, because in that case you receive additional problems, right? You will need to know properties of general definition of base and so on, so on, so on. So avoid it. Darboux sums. Remember, there is also Darboux integral, right? So what is it? We have upper and lower integral. So lower integral is supremum of lower sums, lower Darboux sums, right? And upper integral is infimum of all upper sums, right? And if those integrals are equal, then the function is Darboux integrable. And there was a theorem that Darboux integrability is equivalent to Riemann integrability. It was given only with one part of the proof, and if any proof will be asked, then please try to remember this part of that theorem. So that was in lecture 8, if I remember correctly. I didn't indicate here. I hope I was not mistaken. Okay, question 7. No questions, no questions. Very strange. Very strange. Okay. Question 7. Necessary condition for Riemann integrability. That is proposition 219. And from my point of view, the proof in your lecture notes is extremely short. Extremely short. So I recommend you also to use my lecture where I gave more details. It was lecture 8 of 11 March. Next is question 8, necessary and sufficient condition for Darboux integrability. No analog in lecture notes, so that is precisely from lectures. That is lecture 8 of 11 March, theorem 1. Theorem 1 from this lecture. Okay. Also, question 9 has no analog from lecture notes. Continuity and Riemann integrability. That is from lecture 9, section 8.1, theorem 1. Question 10, monotonicity and Riemann integrability, same section, theorem 2. So, 2 sufficient conditions for Riemann integrability. Why I decided to include it? You have a very general Lebesgue criterion for Riemann integrability in your lecture notes, but without proof. So I prefer to give 2 very important particular cases, but with proofs, complete proofs. Okay, question 11. Question 11. Properties of the Riemann integral. That is from my lectures, section 8.2, the same lecture as before, theorem 1, and in your lecture notes, you can refer to lemma 221 and theorems 221, 222, and 223. Okay, altogether they consist full list of properties of the Riemann integral, which you need to know, of course. Question 12. Newton-Leibniz formula. You have this formula in your lecture notes, but it is given in very general, in fact. Where is it? I didn't give it. Yeah, I give it, yeah. It is given in very general form and the proof refers to a theorem which was given without proof. And I prefer to give slightly different form of the Newton-Leibniz formula, but with complete proof. With complete proof. So I recommend you to use lectures. I mean, video lectures. So that is theorem 1, section 10.1 during lecture 11. Okay, I stopped to indicate dates of lectures. In 11 is theorem 1 only sufficient instead of in 11. Yeah, because theorem 1 of my lectures, as far as I remember, contained many properties. That is why, yeah, theorem 1 is only one theorem, but it has a long list of properties and very long proof, right? So it includes all those assertions together. What is the difference between questions 5 and 13? Question 5 is about integration by parts and substitution formulas for indefinite integral to find primitive, right? And question 13 is about definite integral. And that is, in fact, the proofs are quite different. I'll say a couple of words in future when, just now, in fact, yeah. But you see, once again, Newton-Leibniz formula, here I gave a proof, complete proof, right? In fact, you can find it, I think it's the same as in baby Rudin. Yeah. This one. Okay, 13. Now, integration by parts and change of variable in the definite integral. In your lecture notes, those assertions are given without proof, at least for substitution. Formula for sure, yeah. For integration by parts, I'm not sure. Maybe it's the same. Integration by parts is easier for definite integral, right? And for change of variable, that is more complicated, but nevertheless, why it is more complicated for integration, for change of variable? Because you need a formula, no, sorry, not a formula, a theorem about integrability of a composition, right? I didn't include it into the program, so you don't need to know that theorem, but it is used. It is used in the proof. So you may refer to this proof. So here I refer to my video lectures. That is section 10.2, theorems 1, 2. It's from lecture 11 also, all right? Next, mean value theorems for definite integral. Okay, there are different versions of those theorems. In your lecture notes, second theorem is given without proof. I gave you proofs of both. So section 10.3, theorems 1, 2, same lecture 11. Okay. Question 15 improper integrals, Cauchy criterion, absolute convergence, comparison theorem. It seems here you may refer just to your lecture notes. Section 2.5.2 contains main definitions and formulations. Yeah, second mean value theorem, at least. I mean, in fact, you have no exam tickets, right? So you will be asked some question. So in reality, this program was for oral examination offline, right? And for online, for example, I plan to create more detailed questions, right? For example, like it was for properties of the Riemann integral, right? So there will be different questions and you will be asked just for one thing. So if you will get second mean value theorem, then please prove it, at least for good grade. I gave proof, so what is wrong? Did I promise? No, I don't remember. That I promise to don't ask the proof. I didn't give the full proof? Sure. I did. I did the full proof. I gave the full proof. You have a possibility to watch just now, right? Please watch lecture 11 in a separate window and find it out. If indeed I didn't give full proof. My, really, maybe. Yeah?
For the second mean value theorem, you said that.
No proof.
Yeah, just only.
Only sketch.
Yeah,
Yes, 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 yes. Yes, yes, you are right. You are right. Yeah. In your lecture notes, it is without proof. I did. Yeah. I gave Abel transform, nothing else. Yeah. You are right. Yeah. Okay. Theorem 2, then without proof. Without proof. Okay. Okay. Let me indicate it. I forget. Okay. Question 15. Question 15. Section 2.5.2 from lecture notes is okay. Main things are given. Yeah, question 16. Abel-Dirichlet test for convergence of an improper integral. That is proposition 2, 5, 16. But second part, I think, is given without details in your lecture notes. So I recommend here also to watch lecture 15, where I gave more details for the second part. Okay, question 17. Series, term test, and comparison test. So term test, necessary condition. Convergence. Right? That is term test. So 4, 4, 2 and 4, 3, 1 theorems. Yes. Theorems. Term test and comparison test from your lecture notes. Question 18. Cauchy-Maclaurin integral test. Cauchy-Maclaurin, it seems to me, those names were not used in your lecture notes. But so question 18, that is theorem 437 from lecture notes. Concerning proof, proof in your lecture notes is given geometrically, right? There is a graph with some explanation. So the best thing is to use a combination of this geometrical proof together with analytical proof, which was given in lecture 16, right? All together, that is the best, because in lectures, full details were given of inequalities, and in lecture notes, there is a graph which shows what is going on. Question 19. That is important thing. D'Alembert's test for convergence of series. In your lecture notes, this test is given in a limit form. So 433 is limit form. Or that is corollary of what was given in lectures. So it was section 15.2 from lecture 16. I recommend to you to remember more general form of D'Alembert test. But of course, also you should know limit form, which is given in lecture notes as well, as a particular case. Similar story is about Cauchy test. That is 434 limit form, which is corollary of section 16.1, theorem 1, lecture 17. Next question 21, Cauchy criterion. Absolute and conditional convergence of series of numbers. So this material you may take from lecture notes if you want. So including theorem 4, 5.2. Okay. Then Leibniz test, question 22. That is also from lecture notes, theorem 4.4.2. 23. Dirichlet and Abel test for series of numbers. Theorems 4.4.4 and 4.4.6 from your lecture notes. Then, two questions have no analogues in your lecture notes at all. Rearrangements of series, question 24. Rearrangements of series, that is section 18.1, theorem 1, lecture 19. And multiplication of series. So it's sufficient to know only multiplication of absolutely convergent series. So section 19.1, theorem 1, lecture 20. Yeah, concerning question what you need to know from questions 19 and 20. In fact, it depends on the teacher. Definitely, I'll ask full versions, right? But I'm not sure, at least I'm not going to force other examinators to ask you full versions. So it's up to them if they will be satisfied if you know only limit version or not. That's it. Yeah, I'll ask for full versions. That's for sure. Because you are right when you ask it. If in lecture notes D'Alembert test and Cauchy test are written in limit form, then definitely other teachers may think, oh, maybe limit form was given. Okay. Question 26. Uniform convergence of sequences and series of functions, Cauchy criterion and Weierstrass test. Cauchy criterion was given without proof. Yeah, so it is better to know the general form. That is what I said. Yeah. If you know only limit form, okay. Definitely it is better than to know nothing, but I recommend to know the general form. 24. No. Riemann theorem is not required. The same for multiplication. Mertens theorem also is not required. Even definition of Cauchy product is not required. So only absolutely convergent series, both for rearrangements and for multiplication. Nothing else. Okay. Yeah, concerning question 26. Cauchy criterion was given in lecture notes without proof. I gave you this with proof. So in lecture notes, no, in my lectures, sorry, that is section 21, also 2, and yeah, theorems 1 from both sections. Cauchy criterion and Weierstrass test. It was in lecture 21. That is for uniform convergence. Question 27. Dirichlet and Abel tests for series of functions. Weierstrass test was given also in lecture notes as theorem 553. It's okay also, of course. Weierstrass test is given with proof, so no problem. Concerning question 27, Dirichlet and Abel tests for series of functions. That is theorem. Only Dirichlet test was given in lecture notes as theorem 557, right? So please refer to my lecture, section 20.2, theorems 3 and 4, both Dirichlet and Abel tests, so lecture 21. Lecture 21. Okay. Question 28. Uniform limit theorem or limit of uniformly convergent sequence. Please be careful here, because theorem 531, continuity only. Why it's important? Because quite often uniform limit is used just to prove the existence of a limit, when you don't guarantee continuity. That is important story. Of course, you may reformulate in principle. So, but since it is written uniform limit theorem, that is not about continuity, but just about limits. So refer to theorem 1, section 21.1 from lecture 22. Okay. And yeah, question 29 and 30, you may also look in lecture notes, integration and uniform convergence and differentiation, but also they are given in sections 22.1, theorem 1, lecture 23, and section 22.2, also theorem 1, lecture 23, same lecture. Yeah, that's all what I wanted to say to you. Okay. And I'm waiting for your further questions, more detailed about parts of proofs and so on, maybe some moments and examples and so on. Nothing. About 29 and 30, this question is about, no. 29, integration, no. So what is difference, for example, now I remember, sorry. Concerning questions 29 and 30, there is a difference between lecture notes and my lectures. For example, integration. In your lecture notes, theorem sounds like if both Fn and F are integrated, Riemann integrable, both are Riemann integrable, then you may take integrals, and integrals of Fn converge to the integral of F, right? That is in lecture notes. Both, all functions Fn are supposed to be integrable, but also the limits supposed to be integrable in your lecture notes. And in my lectures, I gave you more general version without this additional supposition about integrability of F. And in fact, the proof that the limit is integrable is very important part. I would say more complicated. Very strange question. We don't have any specific definitions to remember. Of course, you should know every definition from the program. For example, Riemann integrability. There are many definitions inside it, right? Tagit partition and so on, so on, so on. Everything should be known, right? Also, primitive. What is primitive? Yeah, so what is series? What is uniform convergence and so on? Ah, I understand now. There were 3 definitions for the first semester, right? Yeah. Now I remember. There were 3 definitions like limit of a sequence, limit of a limit, limit of a function, and what was third? I forget what was third. Yeah, it doesn't matter. So now it was for the first exam, right? If you survive the first exam, you should learn more. Okay. Yeah, and so I said about question 29, and also there is a for question 30 also there is a difference. In your lecture notes, there is additional supposition that derivatives are continuous. I gave you a theorem without that supposition. So proofs are completely different. How many questions each student will have? It depends on your teacher. Because, you know, for distant examination, there are different styles. Sorry. No, there is no possibility to choose the examiner. For example, in 5, each method needs to be proven in the same way for every condition. For example, in 5. But here proofs are extremely short, right? So it's just differentiate and that's all. In the same way for every condition. I don't understand this part. What means in the same way for every condition? Which condition? I don't understand. During last semester, I distributed students for examinators. Now there will be 4 examinators, and I asked one of those examinators, who is the person responsible in general for foreign students, and she will help me to distribute students among examinators. I don't touch it this time. Okay. Yeah, because, you know, for standard distant exams, there is a possibility for students to choose a lecturer, but it should be given in advance. Now, the time is so pressing, so no such a possibility. Sorry for that. So there is no possibility to choose lecturers and examinator. I hope next semester will do it as it should be. No. Of course, yeah, reschedule, redistributed. Yeah, so everything will be different because it's completely different story now. With distribution about time. I hope that I'll receive the list of my students today to be able to send invitations tomorrow, but up to now I haven't. Yeah, in fact, I asked this question, when will we receive the invitation for exam? That is the question which I cannot answer now. I hope I'll do it tomorrow, because I asked about distribution of students a couple days ago. But so students may have 3 questions from 30. For sure without proofs. Maybe 1 question with proof and 2 more questions without proof. That can be asked from my point of view, because in general, it is supposed that the total time for exam will be around 1 hour. But definitely it's impossible to write down 2 proofs during the time. I mean, of course, we need to reserve extra time to other questions, right? To discuss what you write. So I did during last semester, like, you have half of hour to prepare, and then we discuss what.
And do we need to prove the equivalence between Lakmao integration?
This one? No. In fact, I gave no proof, right? For both sides. I gave only one side. Yeah. And I'm talking about that part. So if I'll ask a proof from this, I'm not sure that, most probably I don't ask. At least, yeah, it is not a good question. More questions? The practical exercises will be exercises like written exam. No, concerning practical exercises, what I was talking about, just for this question, yeah. The only practical exercise which, from my point of view, can be asked is about integration of other functions, yeah, because other topics are covered by written exam. The only important topic which was not covered is about integration. If you ask us question number 6, we only have to write the definition, anything extra. Number 6. I'll not ask question number 6 for sure. It might be, for example, definition of Riemann integral or definition of Darboux integral, something like that. And you need to write all definitions which are necessary. Extra practical question is to find the integral. Practical question. At least I plan to do it. For extra question for other examinators, no idea. Other function not rational. Other function is not rational. And concerning definite or indefinite, it might be that somebody will ask you definite integral. Because of Newton-Leibniz formula, what is difference? Just to substitute, right? After integration, nothing else. Or even, yeah, sometimes it's even easier. For example, there are integrals where you need to find inverse function to hyperbolic, right? After hyperbolic substitution, if you consider indefinite integral. But if you need to compute definite integral, you do it simultaneously and you don't need to find inverse hyperbolic function after. So I don't see any difference between definite or indefinite integrals for computation. More questions? No questions. It seems no more questions. Have you a question? No more. Then, what can I say? Good luck. Oh, sorry. In the time. Concerning extra time, it depends on examinator. And in fact, you know, for example, yeah, it's important. Maybe you will be not able to, how to say, to reproduce the full proof, right? But if you know main ideas and the examinator is sure that you are able to reconstruct all details, it's easy to understand from the first steps, in fact. So, yeah. But in any case, you may ask for extra time. But of course, everything should be in, how to say, yeah, you don't need to ask a lot of time just to remember a definition, for example, of a series, right? no chance. Second mean value theorem without the proof. Yeah, I wrote here. Yeah, I wrote to myself. Yeah. Any information about gradient, since you said that it will be points? For written exam, no idea. It depends not on me. I mean, how your points for written exam will be transferred to grades up to 30. I have no idea what will be chosen. That will be chosen not by me. And if just proved the theorem or answered about other questions, how it will be calculated. Again, it depends on your teacher. So usually it is suggested that your answers during oral examinations are like, if you don't know proofs, then no more than sufficient for. So sufficient for is maximum if you don't know proofs, right? And then it depends on if you know proof, if you are able to reconstruct proof very well, and if you are able to apply your theoretical knowledge for more complicated question, then this is excellent, 8, 9, or 10, right? And if you are no proofs, but not able to produce solutions for more complicated problems, then that's good. Good, again, has 5, 6, and 7, depending on how good you know proofs. That is about how your grade for oral examinations, oral exam will be computed. Absolute minimum required by student to pass. You know, this time, if you want to ask me about those minimal 3 definitions, this time no such minimum exists. In fact, you know, for example, once again, definitions of the limit are necessary for sure. If you don't know definitions of limit, what we are talking about, right? Everywhere are limits. And concerning the proof, if you don't remember the proof fully, but if you are able to, how to say, to produce some logical chains, I would say, right? Then this is, in a certain sense, a part of the proof. That is right. So, as I said, if you don't try to remember proofs, it's another story, right? Then no more than sufficient. If you know all formulations of theorems and so on, then it's sufficient to pass. Okay. Okay. More questions? It seems no more questions. You know, if you have a question, you may ask, you may just raise your hand, right? And then your microphone may be switched on, and then you will be able to ask me without writing. I mean, if it's too long to write a question. So we need to memorize all the definitions studied in the semester. Not all the definitions. All the definitions which are necessary to formulate any question from the program. So we discussed the question from the program, right? So every definition which is used in one of those questions, you need to know. That's it. Only 30 topics. You're right. You are right. You are perfectly right. Only 30 topics you need to know. Only. But these are sometimes very huge topics, right? Okay. Now it seems no more questions. Finally. Then good luck for everybody during final exam. No idea when you will know your preliminary scores. Preliminary scores, if you are talking about oral exam, during exam. If you are talking about written exam, also during oral exam, for sure. You will learn about your grade for written exam. Okay? Okay. And thank you. Bye.